Hi, my name is Bo Yoon, and I'm here to present a time series forecasting with the daily website visit data. The data has a number of website visitors to an academic teaching notes website that was collected from 2014 to 2020. To easily visualize and identify key changes, I decided to reduce it down to 500 days of data. There are four variables in this data, and page loads will be the response variable for the purpose of this study. For model fitting, both ARMA and ARIMA models are used. First, I want to check the stationarity of the data, so I conducted a Dickey-Fuller test in which the outcome rejected the null hypothesis, meaning that the data is stationary. Furthermore, I also wanted to visually check each condition of stationarity. It appears that it has a constant mean around 3,954 and has a constant variance. The data is split in half and each ACF is compared. As a result, all three conditions are pointing to stationarity. The final ARMA model is estimated with parameters that give the lowest AIC. Here, I validated the model with the last 10 days of data. It turns out that the forecasts were tracking the original data pretty well. Also, a rolling window was used to calculate the average ASC across the entire data set. The ARMA model overall did a great job forecasting, as its ability to converge toward the mean matches well with the stationary data. Now, let's take a look at the ARIMA model. First, using the overfitting table with AR 6 and 8, the unit root term is identified. Next, comparing 1 minus b to the 7 and AR 14 tables, the seasonality term is identified. The final ARIMA model is estimated after differencing the trend and seasonality. Using the final model, the last 10 days are forecasted and compared with the actual data. Also, the rolling window ASC came out to be around 13 million, which is slightly less than the ARMA model. Short-term forecasts look good. However, due to having a trend term in the model, the upward trend in the forecasting continues, as well as the prediction limits grow sideways. For long-term forecasting, this model is definitely not a good fit. Here in this new model, instead of taking out the unit root term, I difference the period of 365, which is pretty close to the unit term, and I wanted to see how it changes the forecasting. The forecast bounced up and down and showed a great volatility, even though it's centered around the mean. For this model, the forecast and prediction limits grow sideways as the time goes. The longer the forecasting is, the worse the model performs. In conclusion, three models were created and compared against each other. The model with the best ASC over the last 10 days was ARIMA 311, as it had the trend and seasonality that covered the short-term forecasting pretty well. For the long-term, ARMA model performed the best due to its ability to converge to the mean with stationary data. In the next session, I'll be presenting multivariate time series analysis that utilize other variables in the model. Multiple regression, factor autoregressive, neural network, and ensemble of different models will be compared. This concludes my presentation. Thank you for watching.